So welcome everybody to another episode of Software Architecture on Stream. Today with Kevin Goldsmith. Great to have you on the show. Hi.
Just very happy to be here.
Yeah, thanks for taking the time. And we are going to talk about architecture and organization. Kevin is also going to talk about that at the architecture gathering. So I'm looking forward to that. And in the chat and also in the show notes, there is a code to get 15% off that conference. So Kevin, do you want to introduce yourself?
Absolutely. My name is Kevin Goldsmith. I am the Chief Technology Officer at DistroKid. I am also a founder and principal at Nimble Autonomy, which is a consultancy.
Great. And I guess if you talk about architecture and organization, like the obvious first question is to ask about Conway's law. So what is Conway's law and how does it influence architecture and organization?
So Conway's law dates back to an article that a developer, or architect at the time, Melvin Conway, wrote 50 years ago, more than 50 years ago, actually. And it talks about something that he had observed, and he didn't call it Conway's law. It actually got named Conway's in the Mythical Man Month book by Brooks. But so he just called it he wrote a paper describing this correspondence he saw between the design of the organization and the software architecture that the organization produced. And when he wrote about it, he was actually writing about software design, not software implementation, but software architecture organizations. And he had noticed that if the lines of communication within that organization would exactly mirror the actual software that was produced, and that became known as Conway's law.
Yeah, and as you said, it's actually a very old law, so it's interesting that we still talk about it, or we just started talking about it again.
Yeah.
However, in your talk, and I'm going to put a link to a website with the slides of your talk and also with a recording of your talk in the show notes. So in your talk, you also talk about the mirroring hypothesis. And I have to admit that I never heard about that. So what is it and how is it different?
So the interesting thing about Conway's law is, as I said, he wrote about it so long ago. And when he wrote about it, we write software. I mean, we write software completely differently today than they did back then. However, it keeps coming up. It kind of never went away. It has remained. Like I remember people talking about it in the 90s. I remember people talking about it in the 2000s. And it's because it has always felt so true. People can always see this correspondence. Harvard Business School. So another, I should point out, another kind of interesting thing about Conway's law, as I said, he wrote it as an article. He submitted it to Harvard Business School Review. It was rejected by them because they thought that he hadn't proved this hypothesis well enough. However, it became so present and so omnipresent, so much part of discussion that many decades later, Harvard Business School actually did a study where they were essentially trying to prove Conway's law, but they don't call it Conway's law, they call it the mirroring hypothesis. And it is the same idea. The mirroring hypothesis is that the structure of an organization will determine or strongly influence the software architecture that organization produces. So it's just, it is literally a restatement of Conway's law without mentioning Mel Conway whatsoever, which is unfortunate, but it is very much that idea, the same idea.
Yeah, and I thought it was interesting, as you said, that it's now something that seems to be studied at Harvard. So it seems to be something that is also, interesting to people outside management. So in one of your slides, you actually you cited that mirroring hypothesis, and it says products tend to mirror the architecture architectures of the organizations in which they are developed, this dynamic occurs because the organization's governance structures, problem-solving routines, and communication patterns constrain the space in which it searches for new solutions. So it seems a little bit more general because it talks about products, not just software.
Yeah, I wanted to differentiate, and that is a quote, I think, from the Harvard paper. I wanted to differentiate because it isn't Mel Conway, when he wrote about this, he was working as part of a large, I mean, there were only large industrial kind of companies back then, and he was working as part of a software architecture organization that was completely divorced from implementation. It was probably in a different building, possibly on a different campus of the company. So when they were building things, they were building very, very large systems. Harvard looked at this so much later, and they were just looking at products. And what they were looking at was they looked at a whole bunch of different companies, including open source projects and things like that. And they were looking at the products that these companies produced and the software architecture that informed those products. And they were looking at how modular the software architectures were, which they decided, I think we generally agree that having a more modular software architecture is a good thing. And so that they were saying, well, if that is the desired outcome, do more modular structured organizations produce more modular software architectures? But because they tied it back, I just like that they tied it back to products and not to specific software deliverables, like libraries or something like that. It scales all the way up and down. It's fractal in that way, but I think thinking about it more as products, because that's what we try to think more about is kind of software leaders or software architects, product architecture, as opposed to just a subsec, sub service or those kinds of architectures.
Right. And I should mention, I think that was a good point that you made in the presentation, that because it was in the Harvard Business School, that it also appeals to managers. So it might be, if you want to do a presentation and you want to talk about some managers about Conway's law, you might want to call it the mirroring hypothesis and highlight how it's actually from Harvard.
And any software manager that doesn't know Conway's law should be concerning. But yeah, if you're talking to non-technology managers and you're trying to explain this to them, talking about a Harvard Business School study is always going to get you a lot more trust. Absolutely.
Yeah. So. And as you said, I think that's also interesting that there's this huge body of research nowadays that actually supports these hypotheses.
Yeah.
So you sort of mentioned that, and I want to cite another thing that you put on your slides to the presentation concerning the mirroring hypothesis. So you said, and there it says, we find strong evidence to support the mirroring hypothesis. In all of the pairs we examine, the product developed by the loosely coupled organization is significantly more modular than the product from the tightly coupled organization. And I think that's what you just said. When I saw the slide, I found it interesting that they talk about a loosely coupled organization. Now I totally see how software can be loosely coupled, and that is something that comes up in architecture discussions quite frequently. But what is a loosely coupled organization, and how can I create one?
If I think of sort of the classic or best known loosely coupled organizations, you think of Spotify. I worked at Spotify for a number of years, and that's, I was thinking about this before I went to Spotify, but I certainly got a lot. I grew a lot in my understanding of it there. So if you think back to the Spotify, like squads, tribes model is a loosely coupled organization by design. Amazon did this as well. Netflix is another very loosely coupled organization. And the idea of this, another way of thinking about this, is a true autonomous team structure where teams maybe they work within a framework, but within that framework, they have a lot of freedom in the decisions that they make. the interfaces between teams is very lightly defined, usually maybe through like API or something like that. Full stack teams is a part of this, where you don't have to have teams coordinating so much. A single team can build, test, and release a feature or a product on their own. That is, to me, that autonomous team structure is really the essence, the true essence of a loosely coupled organization. Because if you have that structure, you, by nature, you can't have, if you may have worked, I definitely worked in very tightly coupled organizations where you have to define interfaces between components months in advance, long before implementation, and you're held to kind of very rigid specifications. And that is kind of the exact opposite. Everything gets planned top down. In a loosely coupled organization, each team is kind of working towards a goal on their own, and they'll coordinate, but they don't coordinate very tightly with others. And it's up to each team to kind of figure out how to make that work. Obviously, these companies I mentioned, very successful. So you can build companies successfully that way, but it takes a lot of planning and forethought and being deliberate about it.
So basically, what you're saying is that autonomous teams lead to a loosely coupled organization, and therefore that leads to a loosely coupled modularization, yes. And that's how it basically works. So you just said, and I think that's interesting, that it's hard to build up that structure. Now, how shall I put it? You could you could have the impression that autonomous teams basically means there are no rules. So, and that should be easy to set up, right? Because, right. You just get rid of the rules, and then they do whatever they like, and then they are autonomous. So, yeah. So how is it hard?
So the hard part there is actually there is rules. There's not that there's no rules. I think when companies try and adopt an autonomous team structure, and they do it incorrectly, is they actually think there's no rules. There is absolutely guidelines. There's absolutely expectations on teams. They work within a framework. They deploy within an infrastructure. They're expected to support and maintain their own systems. And so it's not that there's no rules. It's that within the space of play, they actually have a lot of decision making. So ability. So how the actual implementation, the external part of how things work within the infrastructure may be predetermined, but within the context of their systems, they're free, as in APIs, or how other teams will interact with them, how their stuff is built for users. They build within a infrastructure, but they still have a lot of freedom to make decisions and change them. That's the other part of it, be able to change them. So if you're working with another team and you know that their API is going to change, maybe you have the rules in place are, oh no, everything has to be versioned. So you know that you can talk to this version of the API. If they make a change, there'll be a new version number, but you can't tell them you can't change anything, right? So you come up with those kinds of rules to make things work, especially when you talk about the scale of an Amazon or Netflix or Spotify. But within those rules, you have a lot more freedom than you would in one of these very tightly coupled structures. The challenge is not so much. I mean, there's already these frameworks where companies do this, and they can do it at small scale, at middle scale, and big scale. The challenge is that it is an unusual way of working for kind of very traditional companies. You have to learn to build that culture. So, beyond Spotify, Amazon was very deliberate and very, very determined in the way they did this. The entire concept of 2 pizza teams and these kind of autonomous teams, that was fundamental to the way they built the organization. Netflix has a very strong, very similar culture that they built by design, are very deliberate about. Spotify, absolutely very deliberate about. So that's the choice that you have to make, is you have to build your company, your product engineering with this in mind, and you have to do it sort of from the ground up, and that includes management. That's always the hardest part, is management, and I speak as a CTO. Management has to be on board with that and has to accept that you're not going to have the same ability to like push things down into the organization, an autonomous organization. It just doesn't work that way. You have to find different ways to kind of influence and make sure the goals that the teams are working towards are correct. So that's the part that companies really struggle with.
So I could sum it up. To be a little bit provocative, I could sum it up as so you need to do a cultural shift to come up with a loosely coupled modular system on a large scale. Would you agree?
Yeah,
that's basically what you're saying.
Yeah, it is. It is absolutely a culture shift, and it doesn't mean you have to become. It doesn't mean you have to become an Amazon or a Spotify. You don't have to copy those structures. You can create your own structures. Before I was at Spotify, I was trying to build something similar at Adobe, which is not a command and control structure, but also not a true autonomous team structure. And we did it very simply as kind of a first step, just by having each team treat each other team as like external vendors, right? So if you're working with a external vendor, you're using their database or you're using, their product, and something doesn't work quite right. You need this API call to work slightly differently. You can make that request, and maybe they take it, maybe they don't. But if they take it, it's not going to show up for maybe 6 months or a year. So that was the idea that we did within my organization at Adobe, is treat each other, even within this organization, as external vendors. Make your requests, understand that they'll show up later, and then just like you would with an external vendor, you'd say, well, okay, hopefully this will work this way someday, but in the interim, we're just going to work around it. And that's what we did. And that was a very small step towards this kind of bigger culture. But there's lots of things that you can do within your company. You don't have to try and become Spotify or Amazon or Netflix.
Yeah, I think that's a very, very good point. So you have to look for your own way to achieve that. However, does that mean that as an architect, if I want to have a loosely coupled, coarse-grained modularization, I need to work on the organization, and I'm doomed to fail if I focus on just the architecture, on just the software side of things?
Yeah, I think it does make, if you're an architect in an organization, it absolutely puts a lot more stress on you. I've worked in organizations with very traditional kind of architecture roles, where the architect designs the system, maybe to some level of detail, that gets handed into the teams, and then we implement against that design. An architect in the organizations that I've been in, where we have these kind of loosely coupled teams, the architect still exists. Spotify has an architect. Spotify has an architect. I think there's absolutely architects at Amazon. I know some of them. Their role is a little bit different, where there's a bit of an oversight. They're making sure teams are making good decisions. They're working with teams to guide them and give them support and direction, but they're not. Maybe if there is like a big change that needs to happen that's going to affect a lot of things, they'll work across teams and work collaboratively, as opposed to, I've made the design, here's the design, please go implement against my design. So it ends up being still a very critical and important role, but it's much more of a collaborative role. It's much more of involved with the teams and part of the teams, and giving them guidance and challenging their decisions, as opposed to telling them what to do. So it's a very different type of architect role, but still crucial role.
Yeah. So thanks for that insight. So one of the things that you just mentioned is that you could work against that, the Conway's law, whatever. So you could try to build up that modular, loosely coupled thing without working against the organization. And I think that's a good point to ask about the homomorphic force. So that's another term that I learned in your presentation. So what is the homomorphic force?
So homomorphisms in mathematics are a mapping from sort of one structure to another, from a tree to a graph, or a graph to a tree, those kinds of things. So Conway, in his original article, actually talks about this as the homomorphic force. And I think, to be honest, you can go, by the way, like Mel Conway's still alive. He's got a website. The original article's on his website. You should go and read it. It's like 3 pages. It is a very fast read. One of the things that I find really interesting, he did intend it for academic publication, but if you read it, you also understand why it wasn't accepted. It does read a little bit like the equivalent of that at the time of sort of an angry developer blog post, because that's sort of what it was. He talks about homomorphisms in mathematics as a way of, I think, also lending a little bit of more credence or academic background to his hypothesis. But it is this idea, the homomorphic force is something where there is a kind of pressure to make sure these two different representations have equivalences. So it's very difficult to build a graph. If you're going to have to represent the same things in 2 ways, there's a force that kind of forces you into choices you're going to make. So if the idea is that the communication structure of an organization will end up being represented in the software architecture, it's partially because of, if you and I are on different teams, we frankly just don't speak as much. And then if we're on the same team, so if you and I are in different divisions, we're going to speak even less frequently, right? Even if we're working together on a larger project, I'm going to speak to my team. I'm going to speak maybe to the team whose office, who sits next to me on the hallway, or who, is in the same time zone or whatever today. We're going to have much more higher bandwidth communication than you and I are if we're in different countries or in different divisions. And because of that, me and the people I talk to more frequently, we're going to work together a little bit where our things are going to make more sense together than what yours and mine do. And that's what he's really talking about, is that frequency communication creates a kind of understanding that gets lost when you're kind of spanning trees of a hierarchy, of an organizational hierarchy. And so that is that kind of homomorphic force. There's a tree in our software architecture, there's a tree in our organization, and it makes things easier if those things have equivalences to them, because this is how the components work together and this is how the people work together. And so, and back to your original question, this is not like a law of physics or something. This is, essentially a mental exercise. And so my point is that you can do something. You could build a software architecture that doesn't work and that is completely antithetical to the way your organization is structured. There is literally nothing that will stop you from doing that, except because this homomorphic force exists, it makes it very, very difficult, not only for the people in your own organization to understand the software architecture, it just makes it harder, but it also makes it harder for people outside your organization, including your customers, to understand your product, because it's being built in this way that doesn't mirror the communication flows. And what will probably end up happening is your organization communication flows will over time go to match the new software architecture, because it will force teams to talk to each other. And within like a big organization, when you do a reorg, it's like, well, these teams are working together all the time anyway. Let's just put them together in a bigger, division or something. I think over time that homomorphic force will eventually kind of bring Conway's law into effect, and the organization will end up working the same way as the software architecture, or vice versa. It'll just be too hard to maintain these two different maps in your head, your software architecture and your organizational structure.
So there is a question from Michael Reuss at YouTube. So he asks, how could you achieve loosely coupled teams? So it goes back to the question around, loosely coupled teams and these things.
Yeah.
So how could you achieve loosely coupled teams if you're building a physical product, like e.g. a TV set or automotive computers. Do you need to have a mature system architecture before you set up the organization?
It's a great question. I've actually talked to physical goods manufacturers over the years who are interested in kind of building these autonomous team structures. And some companies have actually worked very hard to do that within that kind of that thing. I think within that milieu, I think it is possible, because I know companies are doing it, both in I don't want to name the companies, but I've talked to, but like heavy equipment manufacturing, where they're producing like one of these things a year, but also in fashion or in medical devices. I've talked to companies that were adopting these ideas, where the big challenge here is if you have these autonomous teams designing different things and you actually have like a assembly line, or you have to retool manufacturing facilities, you would think that would be an absolute blocker. But what these companies have done is figured out how to adopt their assembly lines or adopt their manufacturing processes so that essentially each sub-assembly line that's building, they build a componentized hardware architecture where things kind of snap into a grid, and you can modify how that things you can modify within that envelope. And again, you have the constraints like you do within a software architecture, like API or those kinds of things. Like within an envelope, they can have a lot of more reign within that and continue to modify that. You also see a lot, I think EV companies really pioneered this, where you move from kind of thinking about the hardware as its independent platform that is a fixed thing, and moving to doing a little bit more with software, where the software can evolve within the hardware. So we're starting to see that across out of EVs, but that's a sort of another thing, is like making software much more a critical and changeable part of the hardware platform. But to be honest, I am not a hardware person, so I don't know if I can give you a great answer to that, but except to say that companies are working on that in this hardware space, and I've talked to them about what they've been doing. So, and I think that's just continuing to evolve, just because you can think of the lead times you have traditionally with building hardware. It is years of design and then building the factories and retooling the assembly lines. Companies that means that they have a really hard time innovating and being able to change due to market pressures. And we saw some of that even during COVID of supply lines, and like they couldn't adapt their manufacturing to use the components that they could get or things like that. So I think I think even before that, companies were thinking about it just from being more lean. But I think now they're thinking about it also just because they're understanding like they can't rely on some of the ways they used to do things.
So I think what I find interesting is that it sounds like we are talking about some universal principles, like there is this thing that you're designing, and no matter whether it's hardware or software, you have to have some constraints that allow you to collaborate with other teams, and then designing that specific thing, whatever it is, part of some physical stuff or part of some software, then you're free to build that, and that seems to be a universal principle that you could implement in your organization. I think that's what you said. And the other thing that I found interesting is that you said that you probably want to design hardware and software together, which is probably something that we also see with these autonomous teams, where we are building teams that can do database, backend and front end, all of that together, and you could add a hardware component to that. So that seems to be something that I don't think you said it explicitly, but that seems to be a logical conclusion then.
It's the idea of a full stack team, right? So that universal principle you talked about, I think that's always been true. We just solved it a different way. We used to solve it in a different way. So the way we used to solve it was by doing large specifications, debated and argued over many months. Like when I worked on Windows, we would spend a year writing the specification, and it was down to the mouse click keystroke in a text entry box, and you'd get, a stack of paper with that specification. And as developers, we had to go and write exactly to the specification because it was all decided in advance. That has a lot of problems. And least of all is it's completely, if something doesn't work the way you thought it was, it's too bad. You have to figure out how to make it work in that thing because everyone else is depending on it. Now we have full stack teams. Oftentimes that team has the ability to make changes depending on customer feedback. We can also ship a lot faster, like daily or hourly if we want. So as we've changed how we can deliver, and hardware you can deliver a lot faster as well, as we want to be able to do things more and react to our customers more, having these kind of autonomous teams and having these kind of modular architectures make it so that we can adjust the product in near real time based on customer feedback or things changing in the market or in the marketplace.
Yeah, thanks a lot. And by the way, one thing, I'm not sure I mentioned it, so I will put a link to Conway's paper in the show notes, and I would like to second what you said, that it's worth reading that paper. It's really a very, very interesting paper, in particular given that it's older than me, but people were struggling with these kinds of problems back in those days even. We forget how old software, because we think it's so new. We forget software. Our industry has existed a lot longer than any of us. Yeah, and we should definitely take the lessons from those pioneers and listen to them.
Absolutely.
So I think that in your presentation, you said something that made me think, and that is, you said that each team might solve problems slightly differently. So that seems to indicate that there is no best practice even in the same organization. However, if you take a look at some design document or at some conversations between software developers, usually we talk about best practices. So what is the conclusion of that?
An autonomous team structure does not mean there are, coming back to what we talked about earlier, it doesn't mean that there aren't best practices. It doesn't mean that there aren't rules. It's just that what those are either more loosely defined or there's less of them than you would have in a maybe an older style organization. So it may be this is a best practices. Every service should be monitored. Every service should have alerting on it. That alerting should be connected to something that the team is aware of. These are best practices. You should have unit tests for it. You should have test automation. You should have a CI/CD pipeline. These are best practices that you could say within your organization. No, every team should have these things, or depending on how much autonomy you want to give, you could say, well, these are good things to have. You should probably have them, but we're not going to force you to have them. And any team will learn quickly when their service breaks down, and they didn't realize it because they weren't monitoring it, and all of a sudden everybody on the team is getting called because it's affecting customers. They'll realize very quickly, oh, we need to put monitoring and alerting in. So it's really kind of up to the larger organization how rigidly they want to define that. But within that, you might say, well, here are 5 different ways to log. Here are 5 different ways to monitor. Here are 5 different, you have some choices. We're not going to force you to do it this way. Or you might say, we are going to use, we support Java as our primary language, but we're not going to say that Java is the best way to solve every problem. If you need to use Python to solve this, or you need to use Erlang, or you need to use Go, that's fine, but this is how it has to work in order for it to run on the infrastructure supplied by the company. Where, okay, well, you have a little bit more freedom. The problem you have is if, and we had this problem in some of the autonomous organizations I was in, where a team would go, well, we really are excited about Go, so we're going to write a service in Go. And the problem is they didn't need to write in Go. They just chose to write in Go. And after a little while, it became a little bit difficult for them because they had to redevelop in Go all these other things that were already existed and would have been easy for them to use in Java. So they had to spend a lot of time rebuilding things. And after a while, it just became easier to rewrite the service in Java because even though it was fun in Go, it was just, it was becoming a pain. So, I mean, there's ways that you can either explicitly or sort of implicitly say, well, you have some freedom to experiment and to try things, but it has to work within this broader context. And as long as it does that, you have that freedom. But then, of course, you own what you write. So your team is going to be responsible for these choices. So you better make sure that these are the right choices you're making. And this is also where an architect is great, because they can come into the team and ask really difficult questions like, oh, okay, you want to do it this way. That's great. How are you going to monitor? Like, if you were using this other way, you'd get monitoring for free because it's built by the infrastructure team. You're going to have to build it yourself. How are you going to do that? Right. And just make sure that the team is really crisp about their decisions. And again, it depends on how autonomous you want a team to be, where you might actually say, you know what, this isn't going to work. You probably need to do it this other way, but you at least would let them try it or try and prove that that could work that way.
So that's what you would do, because I mean, what you just mentioned is that that team built that service in Go and then eventually rebuild it in Java. So building that service in Go seems like a waste of money and time. From an economic perspective, it might have been the better choice to step in and say, no, you're not going to build that in Go because that's not going to work anyways, or you're going to invest a lot of effort and therefore money in infrastructure that you would get for free in Java, so you shouldn't do that. Would that be your recommendation, or would you let them?
It depends on the organization. I personally have the experience of having been at a much larger, at a very big company, which had a very kind of old style, old school kind of expectations. We were running our own data centers. You had a requisition machine 6 months in advance, all this kind of thing. And I was leading an organization that was building a brand new product. And we had no idea like how many servers we were going to need, because we just didn't know. Is this going to be very successful or very unsuccessful? We just didn't know. So we needed to be able to be much more dynamic. And this organizational structure just didn't want to work that way. And also, in order to work within there, we had to have very specific things. We had to have all this stuff built to make it make sense within the data centers. So we just went and used AWS, and I had to fight, as the leader of the organization, I had to fight our own internal IT company systems really hard to do that, but it just didn't make sense for the product that we were building to kind of be in this very old school environment. And I was lucky that I got support from senior leadership to do this, but that was us kind of going out against kind of the rules, because we had to. And of course, now that company is 100% public cloud, right? They don't have data centers anymore. So because of that experience, I am maybe leaning a little bit more towards this. You can waste a bit of time. You can waste a bit of time. You can waste a bit of money, because maintaining status quo or evolving our architecture very slowly may actually put us in a position where we're moving too slow. And so I tend to lean into giving teams the ability to maybe try something that I'm even skeptical about, and prove to themselves and to the rest of the organization that this might actually be a better way for us to do things. And that has, in prior companies, actually led us into much kind of better software architectures, because if I was going to say, when I was at Avvo, we were a Ruby house, and some teams wanted to experiment with Elixir. And well, okay, they both run on top of Rails, so it's not a huge lift, but we had built all this Ruby infrastructure, and we didn't have any infrastructure for that. But I said, well, okay, go write one service in it. You again, you're going to have to make sure it's monitored. There's the rules, like we can't have it disrupt the service, but go ahead and play with it. And over time, we end up completely, not 100%, but significantly moving on to Elixir because this team proved for a set of problems, it was a much better solution. And we would have never done that if it was like a central decision that either I or a senior a set of senior developers made. And it ended up being much better for the company. So, I want to believe that you hire all these very smart developers and they're paying attention to what's going on in the industry and they're picking up ideas. And if everything has to be decided by me as CTO, I'm going to miss stuff. I'm very happy for us to kind of learn and have things bubble up through the organization. That said, yep, sometimes we're going to waste time. We're going to build a service in Go and then going to have to rewrite it in Java. But maybe it would have worked. Maybe that would have been a thing, and then we'd have to figure out how to make Go a first-class language within our infrastructure over time. Absolutely. I'm more open to that. But then again, it depends on the company. It depends on the context of the company and things like that. In certain companies, like you may not have that level of freedom, especially heavily regulated or heavy governance type of organizations. You may have to do that much more deliberately, but I still want to be open. I call it being opinionated. So we are opinionated about the technologies we're used. We're opinionated about our stack, but it isn't necessarily a rule, and we can play with it and try new things and maybe over time adopt those, and those become the new best practices instead of kind of having everything come up through architect or me or a kind of central decision-making group. I want to hire smart people and have them know stuff I don't and have better ideas than me.
Yeah, I think the metaphor of an experiment is actually quite useful because an experiment is something that, by definition, you don't know the outcome. And as you said, I mean, that Go experiment could have worked, and then it could have been a huge advantage, just as you mentioned, with that Ruby technology.
Yeah.
So there is in your presentation. And we talked about the Conway paper already, but you gave another citation from that paper, and it says it is a natural temptation of the initial designer, the one whose initial design concepts influence the organization of the design effort, to delegate tasks when the apparent complexity of the system approaches its limits of comprehension. So basically, at one point you meet that wall where you can't really deal with that design yourself, and then it says this is the turning point of in the course of the design. Either he struggles to reduce the system to comprehensibility and wins, or else he loses control of it. The outcome is almost predictable if there is schedule pressure and a budget to be managed. So why did you put that on a slide? It has to be important to you. So why is it important to you?
Well, one, it actually it leads to a very quick, easy illustration of why this kind of why Conway's law makes sense and why it works. The idea being that you can imagine, so if you're building a system by yourself and you're designing and you're architecting and you're the sole implementer, you've got the entire system in your head, and that's what Conway was talking about. I as architect, I'm designing the system. I have the entire system in my head, which means that I understand it completely. Great. As the system grows, as whatever you're building becomes more and more complicated, one, it gets harder to hold it all in your head, but two, it also gets harder to implement the whole thing by yourself. And so that's normally when you might, you either simplify the system so you can keep it all in your head, or you get help. You get another developer or another architect to come and help you, and you say like, well, you're better at database and that kind of stuff. So why don't you take over those parts, and I'm going to keep working on the rest. What ends up happening is, well, okay, maybe up till this point you've had the entire thing in your head, you completely understand it. Now there's somebody else, and you explain exactly your intent, and they have some picture of it in their head. Maybe if you're really good, they have the exact same picture of it in their head, but they have different experience than you, and they've learned different things, and they have different ways of solving problems. And over time, what starts to happen is whatever picture you have, these things will start to diverge. And that's kind of natural. That's Conway's law in action. That's like the minute two people, everything was in one person's head. Now it's in two people's head. Now it's going to start to change, and it's going to reflect the fact that each of you is now developing a different picture of the system in your heads, and that's just human nature. That's just how we work as people.
So is that
just to come back? Sorry. The other thing about that is that I like is that it's also an illustration again of how this is kind of an angry blog post from a developer, because what he complains about is if the management, basically if it's schedule or budget, he's like, if you leave me alone, I'll figure out how to simplify the system so I can keep it all in my head and I don't have to split the work with anybody else. But if management says, no, we need this done, Mel, by like October 31st, you need to have somebody else help you. That's where he, in his mind, like the train goes off the rails, because now he has to share the design with somebody else. And now his perfect design is ruined. And that's the part where it just makes me appreciate, him as a person and kind of him when he wrote the article.
Yeah, even though I have to admit, so when I listened to what you said, and I also looked at what it says in the paper.
Yeah.
In the paper, it actually says very clearly, in particular because of the budget constraints, that it's a bad thing to lose control of the architecture. However, when you talked about it, it seemed like a totally sensible approach. You have that database expert, they do something, and you lose control of it, as Melvin said. But that doesn't seem like a necessarily bad thing, because that database expert might even come up with better solutions, as you pointed out, right? I mean, that's basically the point about the experiment. So is it a bad thing to lose control of the architecture?
I don't think it is at all. Yeah, so I actually agree. I agree 100% with you. I disagree. And he doesn't explicitly say, well, he does very much imply like this is a bad thing. And I disagree with many, many, many years ago, Mel Conway. Like, I think today he probably would disagree with himself back then, because we've all learned a lot more. But I think, no, it is a better thing. Like having somebody who is a better database person design your database schemas or your database access, that's a generally good thing if you're not that good at it. And having you focus on the parts that you're good, that is a good thing. And again, that leads us back towards these more modular architectures, because having spread the knowledge, like you have to define, like, if there's a person kind of working on database access and a person working on the back end of the system, and they have to figure out how to work together, you're going to create a sensible interface to make that easy between you. Like, that just makes sense, which is generally good software development, software architecture principles. So I think it actually lends itself to better software architecture. I disagree with the original article there.
Okay, great. And so the other thing, as you said, it's a blog post by some angry developer. So would you agree? And nowadays there is schedule pressure and budgets and these kinds of things, obviously, and it's pretty much constant, because you need to get out as many features as possible. So there is no time at all, basically. So how do you come up with any sensible architecture in these kinds of environments? Or is Melvin wrong in that regard? So what do you think?
When there is, there's always just general time pressure. We're always just trying to get things out faster. But sometimes you have contracts, or you have, a specific date you're trying to get something in this store or something like that, or online or otherwise. So again, I think this is where it isn't anathema to software architecture, but it is more leaning into this idea of your software architecture being modular, being somewhat fluid. Again, going back to when I worked on Windows, which was a long time ago, we were still shipping software on CDs back then, right, and DVDs. We had a very hard date because we needed to press CDs, right? And if you're Microsoft and you're pressing Windows, you have to press a lot of CDs. So you can't really shift that date. Today, almost nothing gets shipped that way. Hardware gets shipped that way, but even hardware, the lead times on hardware have dramatically shortened. So what that means is we can hit a date, we can hit a target, but we can be a lot more fluid in what it is exactly that we're delivering on that date. So if you're contractually obligated to delivering a set of functionality by a date, okay, maybe it's not going to be the exact thing you'd love to deliver, but you can deliver that, meet your contractual agreement, and do that as quickly as you possibly can, and then update after. Or, you know, and you can have the sort of minimum viable software architecture to support that, and then grow that architecture over time. It's not a fixed thing. Like when we shipped Windows, it was done for however many years. Like we could update it, but that was not, you couldn't assume anybody was ever going to see those updates, right? So it's very different now. And that's, I think, one of the things that allows us to do this kind of much more modular architecture, much more autonomous teams, because just the way we deliver software and hardware is really different than it used to be.
So because you have a history at Spotify, and you already mentioned it, so sort of an obvious question is, what is the Spotify model? And, you know, we talked a lot about Conway's law. So what's the relation between the Spotify model and Conway's law?
So Spotify was influenced by Amazon and Netflix and their kind of autonomous team structures. And the idea that Spotify, or the understanding that Spotify had, was that if we want to be a company that innovates quickly and delivers a lot of innovation across a wide area, autonomous teams are the best way to do this, right? And I joined Spotify in spring of 2013. So when I joined the Spotify model, Array existed and teams were already structured this way, but it was still fairly new. But Spotify had been structured not, you know, of less than a year before, in a very much more traditional kind of hierarchical model. It delivered, you know, had a software architecture, was a much more traditional model, kind of layer cake functional teams. And they adjusted that because it was just too slow. Like they couldn't deliver things as fast as they wanted to do. And so this is where they very consciously, because they knew Conway's law, they were aware of Conway's law, they had other organizations that they could look at around this who were good at delivering innovation very quickly. They very consciously kind of did their own version of it, but were influenced by that. And with a very specific goal, again, of delivering as much innovation as quickly as possible across a wide variety of areas. And so with that came in, if you're going to do that model of autonomous teams, you also have to do a model of distributed ownership of systems, right? If you're all working on a monolith, and you have to deliver that monolith as a one big go, it's very difficult for lots of autonomous teams to be doing lots of different things, because it is very easy for them to kind of step on each other's toes a lot. So that implies Spotify adopted a microservice architecture. You don't necessarily have to have a microservice architecture. You could have a small service architecture, but the idea being your services have to be split up so that teams can wholly own them. So because if they are sharing services across multiple teams, those teams have to have a very tight coupling between them, which kind of breaks team autonomy. So Spotify made a lot of these kind of both software architecture and organizational decisions together in tandem to kind of build for the goal of what they were trying to do. And that was like where the Spotify model kind of enters this Conway's law, is that model was designed with a very good understanding of the implications of Conway's law.
So I find it interesting because basically you explained the model in a way, talking about, you know, how you need to get faster, how microservices influence it, and how you need to make sure if you're working on a monolith that you don't step on each other's toes. But you didn't mention, you know, those chapters and guilds and these kinds of things that you have in the Spotify model. So is that intentional? Because it seems like you're putting the focus on something different, which is adjust the architecture, but the organization, but also the architecture. Try to get faster, make up your mind about what works. Is that the essence, or is it more about those organizational measures like guilds and chapters and these kinds of things?
It's mostly because, this is not a talk about necessarily the Spotify. This is not a talk about the Spotify model. It's really talk about loosely coupled organizations. Because I worked at Spotify, I use Spotify as an example. But I also use Avvo, where I worked after, where we did something very different than the Spotify model. The benefit of chapters are really more about personal, professional development for developers, right? So the idea with a chapter, there's a couple benefits to chapters, and I talk about it in kind of other talks or in blog posts I've written. One of the benefits of chapters is you have a boss. Your boss is somebody who comes from your discipline. They understand what you do day to day. They can actually help you grow as a developer. By having a matrix model as well, that allows you some freedom within the organization to move developers to kind of, you can sense in the organization, like, is this team behind? Do they need some extra help? Is this team over here have extra, have a little bit of extra capacity that they could help a team? When you have a much more kind of traditional hierarchical structure, that visibility isn't necessarily clear. Sometimes it is, sometimes it isn't, but the kind of motivations of every engineering manager is for their team to deliver as much as possible. That's usually how they're judged. And so to say, like, I'm going to loan you a developer for my team for 6 months to help you get this thing for your team done, while it is the right thing for the organization, it's not always necessarily the right thing for the engineering manager, right? So it's also, there's something that it just naturally does around aligning incentives to the organization's needs, as opposed to kind of something where it doesn't quite work that way, which is my own experience having been in, like, very traditional kind of IBM. I worked at IBM, I worked at Microsoft, I worked at Adobe, very kind of traditional command and control hierarchies to a more matrixed, more autonomous model. So that's one of the benefits of chapters, but it's independent of the Conway's law. The guild thing, where the guild thing actually has, and to an extent the chapters, has an impact in Conway's law, is one of the understandings is the communication pathways of the organization influence, just by people talking to each other, architectural decisions and best practice. Best practice is kind of floating around the organization. If teams are experimenting and they come out with a better way of doing something, but they're the only ones who knows about it, well, the rest of the organization doesn't benefit from that experiment or knowledge. So having these things that span individual teams, like a chapter within a tribe or like a guild across a company, is a way for good ideas to kind of percolate across the organization and for developers to learn from each other. Because naturally, through Conway's law, if they don't have these kind of spanning type of organizations where they talk to people they wouldn't normally talk to otherwise, good ideas kind of get trapped in these little pockets there. So that's kind of how those things were built with an understanding of Conway's law, but it's also just organizational design.
So one thing that I'm wondering, you just mentioned it yourself, so you did implement a different model at Avvo, even though you had the experience from Spotify, and it seems that everyone in the industry is trying to adopt or copy Spotify. So with you with your expert knowledge about what happened at Spotify, why didn't you use that model and adapt it and used it at Avvo?
I will direct everyone who is ever thinking about adopting the Spotify model to read a blog post I wrote in 2014. I think it was 2014. It may have even been 2013, saying do not copy the Spotify model. And it's not because I don't think it worked. It worked great at Spotify. And by the way, like, Spotify as an organization, I left there in 2016. It's 7 years ago. The Spotify model is completely evolved. Like, it looks very little from it. It looks very different from what it did when I worked there, and what a lot of people think about is the Spotify model. Spotify doesn't talk about it anymore. However, it wasn't that it doesn't work. It was that Spotify had built this very specifically for Spotify. The companies who were trying to copy it were not Spotify. They had a different company culture. They had a different software architecture. They had a lot of different things, which meant that if you just tried to copy it and think that it was going to work, it wouldn't work at all because it wasn't a good fit for your organization. So my instruction was steal the good ideas from Spotify, just as Spotify very openly stole those good ideas from Amazon and Netflix and other companies, and apply them to your own organization. Build something that makes sense for your company and your company culture. Be influenced by those ideas, but don't expect to copy them and have them work. That said, that was a long time ago. I have seen since then companies have adopted either very directly or were influenced by the Spotify model and have actually been successful at it. But certainly up through like 2016, 2017, I saw a lot of companies try to do it and just do it poorly and assume that the Spotify model didn't work, that we were lying about it, when it was really like, no, like you have a very different company culture. It's never going to work because you have to give autonomy to teams. You have to trust your teams. You have to do things in a different way. You're trying to make this, you're adopting the structures without adopting the culture. As we talked about before, it's a cultural change. It's a cultural thing. It's something you have to build very deliberately. I when I went to Avvo is a very different company. Avvo is a very different company. Spotify was also able to grow teams. It's the Spotify model is actually a very people intensive process because you have to have fully autonomous teams. Every team needs everything it needs in order to be successful. Avvo, I didn't have unlimited budget, right? I had to work within kind of a headcount. So adopting that model directly, even if I'd wanted to, wouldn't have been possible. We just I couldn't hire people fast enough to make that work. So instead, we took the good ideas from that. We built an autonomous team structure. I didn't even intend to build a matrix structure. We ended up kind of falling into one because I was comfortable with it. That was fine. I wasn't forcing it. But we ended up adopting a lot of those ideas, but to the Avvo company culture. And it looked similar, but very different. We didn't have chapters. We did have guilds. I think guilds, a lot of companies have just adopted, and they're just as a great way of kind of team people to talk to each other within a company. But we ended up structuring ourselves very differently. We didn't follow the Spotify rules. We kind of invented our own, but again, influenced by those ideas, and that worked exceptionally well for us at Avvo while I was there.
Okay. Thanks a lot. Raw Denim Nerd asked for the link to the blog post, so I will make sure that I actually put it on the website.
Good. Thank you.
And I wasn't able to find it to find it right away, but we'll deal with that.
It's
in a second.
It's on the writing. It's definitely on my website kevingoldsmith.com. There's a writing area. It's on there. You can find the link there.
Yeah, so I will make sure that I will find it. So, anything else you would like to add? Anything that I forgot to?
No, I'm so this just want to promote the conference. This is my second time, I think, at this conference. It's difficult for me because it's virtual and I'm on the west coast of the US, so I'm going to end up probably watching a lot of it later. But I very much appreciate just having this kind of software architecture focused conference, and especially having it virtual means that you get to see every part of it. And this talk in particular, it is not, just to be clear, it is not I certainly talk about Spotify because I worked there and I have experience there, but it is really just this idea around how your software architecture and your organization are linked. And there's a lot of things that really the homomorphic force, but there's actually even I talk about there's a part of your brain that actually makes the entorhinal complex actually kind of wants to have this homomorphic force, this mirroring hypothesis. So where it's helpful for architects, software architects in their day-to-day work is just understanding at a deeper level the forces that kind of, if you build this ideal architecture and it never gets done right, maybe you need to look at the organization and think about the organization as you're thinking about your software architectures.
Yeah, thanks a lot. So I found a blog post called Thoughts on Emulating Spotify's Matrix Organization Other Companies. Okay, so then that's the one, and I will put it in.
Yeah, I should have named it better.
So it's in the chat now, and I will make sure that it's also in the show notes later on. So thanks a lot. Thanks a lot for sharing all the insights, and have a great day.
Thank you. You too. Have a good evening.
Yeah, thanks.